Fantastic. Well done if you gave that a try. Let's see what we get from this. Okay, so the first question there was to determine the correlation coefficient of the data. So again, we need to use the statistics mode on our calculator, and we're going to select the a plus bx. If you've got this sort of calculator here, that helps us to do linear correlation, right? So we've got 178, 194, 153, 167, 184, 188, 172, 156, and then 149. Okay, so this says I've got 9 data points, so I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I do have 9 data points, and that means it's probably true that I've put all the x values in here correctly. And then I'm going to make sure that I put the y values in that correspond. So I've got the 74, the 99, 78, 67, 74, 88, 76, 56, and 49. And then I see each and every x value does have a corresponding y value, so it's likely that I've put it in correctly. Okay, so now shift, stat, and again option 5 is going to tell me about regression, and if I select number 3, I get here a correlation coefficient of 0.81. Okay, right, so this 0.81 is our correlation coefficient. And then it says we've got to determine the equation of the least squares regression line. So now again, shift stat, option 5 is regression, and that then allows me to select number 1, which gives me a, the y-intercept. So I'm going to get y is equal to negative 57,27, and then plus the bx. So shift stat reg, option 2 gives me b, and then I get 0.76. Okay, so that's then 0.76 times the x value, which is the height. Now, an interesting way to interpret that gradient, the 0.76, is to say that for every 1 centimeter that somebody gets taller, they're likely to gain 0.76 kilograms of mass. Then we have to describe the relationship between height and weight. Now, because we've got this 0.81, that is very, well, it's quite close to 1, and it's a positive value, we can say that there is a, and here I'm just going to combine the words moderately and strong, because I said moderate is like 0.5, I said strong is 0.9, but yeah, so I'm going to say it's a moderately strong, instead of a strongly moderate, a moderately strong positive correlation. Okay, so what does that mean? We know it means that as height increases, right, so does weight. Okay. Right, so then we can continue, and then you are asked to estimate the weight of a person who is 175 centimeters tall. Right, so here you have to use your least squares regression line, and you know that your least squares regression line was calculated as negative 57.27 plus the 0.76x. So if you're going to estimate the weight of a person who is 175 centimeters, the weight, you know, is your x variable. So in order to go and calculate this, you're going to use your least squares regression line. So let's write that. We've got negative 57.27 plus 0.76x. Okay, and now we have to substitute in for x. So negative 57.27 plus 0.76, and we want to predict for 175. So there we go, 175. And then we're going to just put it into a calculator. So negative 57.2 plus the 0.76 times the 175. And my prediction is that if somebody is 175 centimeters tall, they are going to weigh 75.8 kilograms. Then we have to go and estimate the height of a person who weighs 83 kilograms. So now we're just going to substitute in for y instead of for x, because we know that weight is our y variable. So 83 is equal to the negative 57.27 plus the 0.76 times the x, and now we just need to isolate the x. So 83, I'm going to take that to the other side, that's going to be plus 57.27, and then I've got 0.76x, I just want x. So I'm going to divide both sides by 0.76, and that would isolate the x. So now I'm going to use my calculator, right, and we've got 83 plus 57.27 divided by 0.76. Okay, and that gives us an answer of 184.57. Okay, so we predict that if somebody weighs 83 kilograms, they are going to be 184.57 centimeters tall. Okay, so then we've got to go and calculate the arithmetic mean of the weight. Now, when you use the stats mode in your calculator, you actually have some advantages by just remaining in that stats mode and keeping that data in your calculator. And the advantage is that your calculator is able to go and do the regression calculations, but it can also go and calculate the statistics for these individual x and y values. Right, so when you've got your table that you've put into your stat, you can again use the shift stat, and then instead of selecting option 5, if you should select option 4 for variables or variance or whatever, you then get a different menu where you can select n, you can select x bar, which is the mean of x, you can select sigma x, which is the standard deviation of x, you can select y bar, which is the mean of y, and you can use sigma y, which is the standard deviation of y. Now that number 4 and number 7 that says sx and sy, that refers to something called the sample standard deviation, and we don't deal with that. We always use the one that says sigma, that actually means the population standard deviation, but you'll learn more about that in future if you take statistics courses in varsity. Okay, so to calculate the arithmetic mean of the weight, that is the mean of the y variables, that was the weight, right? So here I'm going to select for option 5 for y bar, and I'm going to get that the mean weight was 73.44. Then we've got to calculate the variance of the height. So now I'm going to go shift stat again, and in order to find the variance of the height, I'm first going to find the standard deviation. So remember that sigma is the standard deviation, and sigma squared is the variance. So if I select this option 3 here, I get sigma x. So the standard deviation of x, the height, is 15.22. Okay, and then in order to get the variance, I'm simply going to square that value, and I'm going to get 231.73. And then the next question asks us, if we use our data to predict the height of a person who weighs 160 kilograms, we are likely to be wrong. Why is that the case? Well, the reason for this is that 160 kilograms is way outside of the data that we collected, right? So the heaviest person we dealt with was 99 kilograms. 160 kilograms is another 61 past that, okay? So if we use this weight of 160 to go and predict a height, we would be extrapolating big time. And it's very likely that the trend doesn't continue. So past a certain point, as people get heavier, it's probably not that they're getting taller, it's probably that they're getting wider, maybe a bit more muscular if they're bodybuilders or rugby players or something like that. Okay, so we'll be wrong there because we're extrapolating way outside of the data that we actually have. And then for J, we've got to calculate the mean point. Now, the mean point is literally just the mean of either of these two things. So it's X bar, Y bar, right? And Y bar we've already got from G, right? So the mean of Y was at 73.44. And then to get the mean of X, we're simply going to do the same thing again and select the mean of X in our calculators, and I get here the 171.22. Okay, so that's going to be our mean point. And that was the last question that you were asked to find. So I just want to show you here what our scatter plot looks like. And our scatter plot has got the points there, and we can see that there's a general linear relationship. And if we were to draw in our line of best fit, that would probably confirm that. So that's all I've got for you today in terms of bivariate data and statistics. Thanks for joining me. Have a good one. I will see you next time.